Good evening. This is VK3EKH, the official station of the Astronomical Society of Victoria with the regular Friday night broadcast. Coming to you from the studios of VK3CSJ in Narre Warren South, broadcasting on prime frequency of 3541 kilohertz in the 80 metre amateur radio band, and also via the Melbourne television repeater VK3RTV digital channel 1 to the masses all around Melbourne, and also on the British Amateur Television Club video streamer. If you go to the batc.com website and look up the video streamer and look for VK3RTV1 active on active repeaters, you'll see the feed from there. At least I think it's there. But if you go to my YouTube channel, VK3CSJ, look for the live indication. Hopefully for the next hour, you'll be able to see the YouTube feed in full HD. And also on Discord. As I say every week, Discord is the preferred way to view the graphics aspect of the broadcast. If you don't have access to Melbourne TV repeater, from the point of view that the video is less than a second delay from what you're hearing of me talking on 80 metres, whereas with YouTube it's anything up to 20 seconds. Nevertheless, we are on Discord, my Discord channel. If you're not registered with Discord, register. Just go to discord.com and register. Just type in Discord in your favourite search engine and look for Discord and then register. There's a few fiddly things you have to do. There's no cost involved, and there's a username and password which I recommend that you write down somewhere, because if you forget your password and you come back to Discord later on and you forget your password, that's where things get a bit tricky. So don't forget your password on Discord. But if you go to my qrz.com page for VK3CSJ or VK3EKH, I provide a universal link, for want of a better term, which will allow you to access the astronomy chat room, and that is of course linked to the video channel as well. So we normally have 4 or 5 stations a week that log in onto the Discord channel, so it's becoming slowly popular. But of course YouTube is the other way of doing it. You can always turn the volume down on YouTube and just listen to the bilge coming from here, and just put up with the 20-second delay. Nevertheless, we have an email address, vk3ekh@gmail.com, vk3ekh@gmail.com, where you can send signal reports to me whilst I'm on air, and all that sort of thing. So I think all my audio levels are okay today. So let me know if everything is sounding all right. I think the audio feed to YouTube should be okay, looking at my level on vMix. Anyway, welcome to this Friday's session of the broadcast, ASV radio broadcast, Astronomical Society of Victoria. Been broadcasting since 1988, courtesy of Russell Ward, VK3DRW, for the first 20 years, and then handing the microphone over to me about 12 years ago. Actually, a bit more than that, I think. Anyway, so I've got a few more years to catch up to that record, and then I'll seriously think about whether I'm continue doing this. What else? Anyway, it's coming up to a new month. September is just around the corner. On Monday, a new month. So we are turning from winter into spring. I'm pretty sure all of us will be glad to kiss this winter goodbye. So from what I read on Jane Bunn's website, or what she said in the report tonight, is that by the end of the week we'll be up to 20 degrees with the temperature. So hopefully that marks a turn in the seasons and slightly warmer weather. But certainly this weekend, particularly tonight and tomorrow, will be a freezing. And I can see already it's 9.2 degrees here in Narre Warren South at the moment and dropping. There's a wind coming in from the northwest at about 10 kilometres an hour. That's bound to increase. Apparently it's going to get very, very windy from midnight onwards. And apparently there was a tornado alert over in Adelaide today. The wind was such that there was a tornado threat. And I did see some video footage of didn't look like a tornado, but it was certainly a very strong wind that hit somebody's backyard for a moment and everything went flying. So, anyway, there it is. So the weather is going to be rather exciting in the next few hours, and it's all coming up from the south. You look at the cloud satellite imagery, and when you get the spotty cloud cover, that usually indicates cold air. So and it's all coming up from Antarctica. That last kick of winter. All right, now because we're coming into a new month, of course, Tanya Hill, the resident astronomer at the planetarium at ScienceWorks, has produced her sky notes for September. So we're going to kick off going through the sky notes. What's up in the sky? What's happening in the sky for September? What to look out for? To give you a quick rundown of the articles tonight. Just to give you your appetite to hang around for the full hour. There's we have courtesy of astronomy.com. To find alien life, try eavesdropping on their conversations with spacecraft, astronomers suggest. That's a little bit of an update from the SETI people. Also courtesy of astronomy.com, we have a little bit of an acknowledgement of the birth of Katherine Johnson. Today, this is August 26th. Today in the history of astronomy, the pioneering hidden figure is born in reference to the movie Hidden Figures. If you haven't seen it, recommend it. Also an interesting article on water on Mercury. Let me see. The title here is actually August 23rd, 1991, Water on Mercury. But it is published 23rd of August. So, you just have to wait around for that article. There's an interesting image there. Courtesy of Science Alert, we have world's most powerful solar telescope captures its first monster flare in astonishing detail. Well, we'll see when we get to that. And then we jump to the space weather report. So it should be a relatively short session tonight. No video from Tamitha Scove, although there was one earlier in the week which I ran last Sunday. And I'm now a Patreon of Tamitha Scove's information page. I don't know why I didn't do that a long time ago, but I've already had a little bit of a keyboard-to-keyboard message with or text with Tamitha, so she's happy that I'm on board with her Patreon thing. But as a result of being a Patreon, I now get information a little bit earlier to me before she actually publishes it to YouTube, which could be of some benefit for this Friday night thing that I do. All right, and then space weather report. So we'll see how we go with all that. Anyway, having whet your appetites, if that's what I've done, I don't know. Let's have a quick look at email. Nothing has come through on email. Like I say, you can send us a signal report vk3ekh@gmail.com. Quick look at Discord. I see Cassiopeia is there, and Andrew, Mr. KIS. G'day, Andrew, and Nebs. So they're viewing me in real time. All right, welcome, guys. So now let's just kick off. Now, last week I introduced an AI audio. I haven't completely fixed that all up yet, so I won't do it tonight. But when it comes to doing the usual blurb on the ASV, I'm going to try and get that recorded so I don't have to worry about it myself. Because reading from the book, I should know this stuff off by heart because I do it every week. But nevertheless, for those that are tuning in for the first time and don't know anything about the Astronomical Society of Victoria, it was founded in 1922. It has well over 1,600 members scattered about the country and overseas. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy, to disseminate knowledge of the science, and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month. These meetings kick off at 8 o'clock and aim to finish at 10 o'clock at the Mulia Hall, National Herbarium at Bowen Avenue in Melbourne, near the Melbourne Observatory, not too far from the Shrine of Remembrance. Parking is available in Bowen Avenue, Dallas Brooks Drive and surrounding streets. Admission is free and visitors are most welcome, so you don't have to be a member of the ASV to wander up to the National Herbarium at 8 o'clock on the monthly meetings. These monthly meetings are also beamed to YouTube. ASV has its YouTube channel. So when it comes to the monthly meetings, if you can't make it to the meetings, you can view it on YouTube and or on Zoom. And, well, not so much Zoom, Facebook, their Facebook channel. If you're onto Facebook, privileges of membership include the right to borrow books, periodicals and publications from the Society's extensive library located at the Melbourne Observatory. And it's one hell of a library. Receipt of the ASV magazine Crux, which contains articles, news, observing notes, and stories from members. The free provision of the Astronomical Yearbook, which is kind of like an almanac of sorts, published by the ASV every year. It's quite a decent publication. That's what I'm reading from right now. This is the almanac. Well, it's not called an almanac. It's called the Astronomical Yearbook 2024 is this one. So it's a reasonable little publication that the ASV does on a regular basis, annual basis, full of interesting astronomical facts. Regular, missed this paragraph. Access is available to telescopes on members' nights held regularly at Melbourne Observatory and after the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's a 200mm refractor, which is managed by the Royal Botanic Gardens, and a photoheliograph are also housed at the observatory and accessible to members as well. The Society also has a number of 200mm reflectors available for short period loan in the telescope loan scheme that the ASV does. Regular Society Club night meetings are held at the Melbourne Observatory in the Ellery Suite in Burwood Avenue, opposite the Shrine of Remembrance. Members are encouraged to use the Society's instruments located there in order to gain first-hand experience in telescope use. These instruments include a 508mm equatorial reflector and a number of smaller reflectors. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use. The larger 2 only with appropriate training, which range from 300mm to 1000mm in aperture. Also located on site is a fully steerable 8.5 metre radio telescope, a DS Kennedy dish, which members can access with involvement in the radio astronomy section. Welcome to any radio astronomy members that might be watching tonight. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. Other areas of interest that members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral meteor comet radio astronomy, computing, cosmology and astrophysics, historical studies, research and astronomy in general. There's anything up to about, I think, 20 sections that are active. Contact details for various section directors are provided in the yearbook, but if you don't have the yearbook, you can only be a member to have the yearbook. You can access all this information via the website at www.asv.org.au. That's www.asv.org.au. There you'll find information on those individual sections and the section directors and how to contact them, and to see if you're interested in participating in one of their meetings. I think generally most sections will welcome visitors for the first time and as a guest. And then of course you'll be informed about how to become a member if you want to continue on. The ASV will conform to any government health directives. In that respect, some things may be cancelled, moved or postponed. If you wish to write a letter to the ASV via post, address a letter to the Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. But basically, if you go to the ASV website, all you need to know is there and find, and that's about it on that. I've been a member of the ASV since around 1993, around about the time that Comet Shoemaker Levy 9 impacted with Jupiter, which was a very interesting time for everybody that was interested in that sort of thing. And I got involved with the radio astronomy section and didn't look back. It has been an exciting time over all of these years. So anyway, the RIS section is moving along very well at the moment. All right, 20 past the hour almost. Let's get into the sky notes and see what Tanya. It sounds the same. Tanya. Anyway, let's see what Tanya Hill has to say. And she says something about a new camera and new astronomy. I can hear a noise in the background. I'm being distracted. I think that's just one of my cats playing. I think so. Better be. All right. Sorry, I'm being distracted. Researchers at the Indian Institute of Science have developed an eye-like or neuromorphic camera better able to detect fainter or faster moving objects than conventional charged coupled devices or CCD cameras. Experimental results include the faint star in Sirius B, seen alongside its far brighter companion Sirius A, a high velocity meteorite passing near the bright moon, and small moons orbiting Saturn and its bright rings. Standard cameras can mask bright objects to reveal faint light sources, but they struggle with oversaturation, and stacking different exposure times to produce a composite image has its limits. Conventional CCD cameras are also poor at seeing fast-moving objects, which produce unwanted motion blurring. The new camera sidesteps these issues by using much higher frame rates to sample incoming protons, and, crucially, detects them by using a logarithmic rather than a traditional linear scale. It can detect very bright and very faint objects simultaneously. The camera's pixel response to incoming light can be set to a specific threshold to avoid overexposure. As a result, as researchers claim, the new camera is inspired by the human retina, preserving details across wide range of luminosities. It also uses far less power, an asset in space probes or space telescopes where there are typically tight constraints on power. The new low-power camera offers potential in fields outside of astronomy for observing faint or fast-moving objects in circumstances of varying light intensity. Now, she's got a couple of images here. I'll just bring that up. Where are you? I think that's the first image here. So what she's got here is distinguishing Series B from Series A in one image is possible, as is separating small faint moons of Saturn against the planets and its rings. The color bars at right indicate pixel intensity on a logarithmic scale. So I think what she's saying is that the new camera, as a result of this new camera design, by looking at Series A and Series B, you're able to distinguish the two objects, whereas before with normal cameras you can't do that unless you do some trickery. And the other picture she's got here is of Saturn, which is this one, if I can find it. Where's our Saturn image? There it is. So again, using this new camera, where Saturn would normally be too bright and would swamp the faint light coming in from the moons, the new camera is able to distinguish Saturn at the same time being able to resolve the moons, even though that's not a very clear image. But I guess that's just suggesting that it's an improvement over the normal technology. Yeah, well, anyway, stay tuned on that one. We'll see what that's all about as time moves on. But it seems like it's an interesting camera design that they've come up with. All right, continuing on with the Sky Notes. Okay, just before I do, that introduction to a new camera for new astronomy is, again, you can read this on the ScienceWorks website, museumvictoria.com.au, and type in planetarium, or look for the planetarium, look for Sky Notes basically, and you can find out that information about that camera that I've just read. But what Tanya has provided are 3 links just below those images that I just showed you, and the 3 links talk in more detail about this new camera: enhancing celestial imaging, cameras that work like our eyes, and neuromorphic vision, all courtesy of the Indian Institute of Science. All right, the spring equinox. Here in the southern hemisphere, we are about to experience spring equinox. This is when day and night are effectively the same length. This will occur on Tuesday the 23rd and marks the end of winter and the beginning of spring in the southern hemisphere, and the transition from summer to autumn in the northern hemisphere. At the equator, at an equinox, the noon sun sits directly overhead, and both hemispheres receive equal hours of daylight. However, away from the equator, the sun's path in the sky is midway between its high, long summer arc and its low, short winter one. The main reason for the seasons lies in our planet's tilted axis of rotation, which is 23.5 degrees, with respect to its orbit around the sun. At an equinox, neither hemisphere leans toward or away from the sun. However, local day and night are not exactly equal at the equinox. Astronomical timings are based on how long the center point of the sun's disk is above the horizon. At local day effectively starts when the leading edge of the limb of the sun broaches the eastern horizon and ends when its trailing edge or limb drops below the western horizon. There is also a terrestrial effect as well. The Earth's atmosphere refracts or bends light from the sun so that at sunrise we get the first glimpse of the sun before it physically crosses the local horizon. The reverse occurs at sunset, when we see the sun for a few minutes after it has already sunk below the western horizon. Melbourne sun times. On Monday the 1st of September, the sun will rise at 6:42 a.m, setting at 5:58 p.m, with the day length being 11 hours and 16 minutes. Thursday the 11th of September, sunrise will be at 6:27 a.m, setting at 6:07 p.m, and the day length will be 11 hours and 40 minutes. On Sunday the 21st, sunrise will be at 6:11 a.m, setting at 6:15 p.m, with the day length being 12 hours and 4 minutes. And then by the end of the month, on Tuesday the 30th of September, sunrise will be at 5:57 a.m, setting at 6:23 p.m, with the day length going out to 12 hours and 25 minutes. So our days are getting longer. Moon phases. There's a full moon on Monday the 8th, a third quarter on Sunday the 14th, a new moon on Monday the 22nd, and a first quarter phase on Tuesday the 30th. Moon distances. The lunar apogee furthest from the Earth is on Friday the 26th at 405,548 kilometres. At lunar perigee, which is closest to the Earth, is on Friday the 26th at 364,777 kilometres. As I say, you can almost throw a stone at it. Planets. Mercury is soon to pass behind the Sun and is not visible this month. Venus is just still visible in the east from 5 a.m. before fading by dawn's early light. Mars is soon to move behind the Sun for its solar conjunction, but will remain visible this month from 6:50 p.m. in the west until it sets by 8 p.m. So you can still view Mars for a little bit longer in the afternoon. Jupiter has now passed behind the Sun and can now be seen rising in the east around 3:30 a.m. before fading in the northwest by dawn. It will be visible a little earlier each morning during the month. Saturn is nearing opposition and can be seen rising at the east, or in the east, at 8 p.m. and transversing the north until being lost from view in the west by dawn. Like Jupiter, it will appear a little earlier each evening. Meteors. While not a good time for meteors this month, the southern Perseids will peak from the 11th to the 20th. They usually number only a few per hour and appear in the constellation of Pisces, the fish, which rises in the northwest from midnight. Find out more about these space visitors at NASA's Asteroids, Comets and Meteors. That's a link she provides there. Stars and constellations. If we face towards the north, high in the north is Sagittarius, with its bow and arrow forming the famous asterism, the teapot, the spout of which leads across the zenith to the curving tail of nearby Scorpius. Lower in the north sits Aquila, the eagle, with Altar and Alpha Aquilae, with 12, which is the 12th brightest star at night, and quite low in the north is Lyra, and its principal star is Vega, or Alpha Lyra, which is the 5th brightest star at night. In the east, if we turn to the east, directly east this month is a trio of adjacent constellations. In the center is Aquarius, the water bearer, while above is Capricornus, the goat, and to its left sits Pisces Austrinus, which is the southern fish, with its principal star Fomalhaut, or Alpha Pisces Austrinus. These Latin words always get me. If we turn to the south, low in the southwest can easily be seen two of the brightest stars in the night sky, Alpha and Beta Centauri. Centauri. Somebody pronounced Centauri differently the other day. I heard that. I thought, why would you say that? It's Centauri. But then what can I say about that sort of stuff? Centauri. They pronounce that differently. Centauri, Centaur. Okay, it doesn't matter. These are the two biggest stars in the constellation Centaurus, the Centaur, with Alpha Centauri also known as Regal Centaurus, spelt with a K. Together, these two stars are referred to as the pointers, as they lead directly to the unmistakable diamond shape of the Crux, or the Southern Cross. Crux is the smallest of traditional 88 constellations astronomers use, and is an easy feature of the night sky to observe even in city surroundings. In the southeast is the 10th brightest star Echina in the long constellation Eridanus, the river that winds its way down to the horizon. If we turn our chairs to the west, high in the west sits the curving tail, body and pinches of the Scorpius. Within its body you should be able to see red giant star Antares, which will appear more orange than red in light polluted skies. And in front of Scorpion's wide head and closer to the horizon sits Libra, the scales. So, if you're not familiar with the constellations of the sky, it's probably one of the easiest things to learn about. Most star programs, if not all star programs, usually have the constellations dotted through the sky, so you can get an idea of what man imagined were in the sky many centuries ago. Anyway, International Space Station. At a distance of about 400 kilometres, the International Space Station completes an orbit every 90 minutes, and it appears as a bright object that moves slowly across the night sky. There will be many visible passes this month over Melbourne and central Victoria. Here are some of the brightest and highest in elevation this month. So on Tuesday the 16th of September is a passing at 5:20 in the morning, on the morning of Tuesday the 16th, 5:20 a.m. to 5:27 a.m, coming in from the northwest to the southeast. On Thursday the 18th, there's a passing. It starts at 5:20 a.m. to 5:26 a.m, coming in from the west-northwest to the southeast. And then on Friday the 19th of September in the morning, there's a passing at 4:33 a.m. to 4:37 a.m, southeast to the southwest. I suspect that most of these particular passes that Tanya puts down are pretty much overhead passes, because the International Space Station does pass over Melbourne on a more regular basis, but at just different angles in the sky. So these ones would be most likely directly overhead type passes. But if you go to the Heavens Above website, Heavens Above gives predictions for visible passes of space stations and major satellites, live sky views, 3D visualizations. Be sure to enter your location under the configuration tab. But heavensabove.com is a brilliant website for finding out what's in the sky. It has a total list of satellites, amateur satellites, all celestial objects, where they are, maps, and all that sort of thing. All right, time is moving along. I suspect that I'm not going to have enough time for those articles that I've got here. Oh, cold coffee. Duh. So I'll read out just a few dates. On this day, on the 1st of September 1939, Americans J. Robert Oppenheimer and Hartland Schneider published the first paper that describes the gravitational contraction of a star, which later led to the modern concept of black holes. Also on the 1st of September 1859 was the Carrington event, which we've mentioned here several times in the past. Carrington event, most powerful geomagnetic storm ever recorded, now understood as a coronal mass ejection, CME, from the sun that hit Earth's magnetosphere, inducing a strong northern auroras almost to the equator, and telegraph interference in Europe and North America, with operators receiving electric shocks, poles were sparking, and signals sent despite power being cut off. We need more of those geomagnetic storms. On the 1st of September 1979, Pioneer 11 made the first flyby of Saturn, returning the first close-up images of the planet. It was the second probe to pass the asteroid belt and Jupiter and to reach solar escape velocity. Last returned contact was on 30th September 1995, and final data received was on November 1995. On the 5th of September 1977, Voyager 1 is launched to explore the outer solar system. After 42 years, it continues sending data and is the most distant probe at 21.8 billion kilometres, or 146 AU. It entered interstellar space in 2012, and its power supply may last until 2025. On the 8th of September 2004, Genesis, the Genesis probe, which was featured in Star Trek, crashed. Forget that I said that. On the 8th of September 2004, Genesis, a probe, crashes in Utah while returning samples of solar wind particles. Nothing like the Genesis that was in Star Trek. You have to be a Star Trek fan to know what I'm talking about there. On the 11th of September 1985, the International Cometary Explorer, or ICE, became the first spacecraft to encounter a comet by flying through the dust trail of comet Giacobini-Zinner. And just one more date. On the 14th of September 1959, Luna 2 by the USSR, was the first craft to fly to and impact another body. In this case, the moon. It released sodium gas to allow visible tracking, used radio for telemetry transmission, and crashed into Mare Imbrium, or in other words, the Sea of Rains. I hate those Latin words. Anyway, enough of that. I'll finish off those dates next week. Thanks, Tanya Hill, for your Sky Notes. If you want to catch up with those Sky Notes yourself, like I say, just visit ScienceWorks, Melbourne Museum, or the Planetarium, and look for Sky Notes by Tanya Hill, resident. Oh, I forgot to. I had a picture I was going to show of Tanya. This is Tanya. I had a picture here, which I was going to feature while I was waffled away. But that's our resident astronomer at the Planetarium at ScienceWorks, and I've had a chance to meet her a couple of times. So a nice lady. All right, let's get into these articles very quickly. Let's have just a quick look at this. All right. Okay, and I'll bring up this slide. Where's the slide? There's the slide. And I'll insert me in the top there. Okay, to find alien life, try eavesdropping on their conversations with spacecraft, astronomers suggest. What if aliens are just like us? A new search for extraterrestrial intelligence uses Earth's transmissions as a guide to find signals from other worlds. Published August 21. A new study suggests a novel approach in the long-running scientific endeavour to find intelligent life beyond Earth. Instead of casting a wide speculative net across the cosmos, researchers from Penn State and NASA's Jet Propulsion Laboratory propose a more targeted strategy. Listen for alien civilizations in the same way they might be listening for us. By analysing our deep space communications, they've identified specific patterns that could aid in the search for extraterrestrial intelligence, or SETI. Their paper, to be published in the Astrophysical Journal Letters, argues that the key may lie in looking for the spillover from routine interplanetary conversations. So, what is SETI though? The search for extraterrestrial intelligence, or SETI, is a scientific field dedicated to finding evidence of technological life elsewhere in the universe. It's a quest that began in 1960 when astronomer Frank Drake pointed a radio telescope at two nearby sun-like stars, hoping to catch a stray signal. While that initial search, which was called Project Ozma, came up empty, it ignited a global effort that has continued for over 6 decades. SETI operates on the assumption that if other intelligent species exist, they might be using technology like radio waves that we could detect. Early SETI efforts were sporadic and limited by available equipment. The field gained momentum when projects like the Big Ear telescope at Ohio State University, which in 1977 detected the famous WOW signal, a powerful narrowband radio signal that remains an unexplained candidate for an extraterrestrial transmission. Over the years, the search for these techno signatures has become more sophisticated. Beyond listening for radio signals or looking for laser pulses, modern SETI also considers searching for signs of massive scale engineering, such as the waste heat from Dyson sphere built to enclose a star, or even industrial pollutants in the atmosphere of an exoplanet. The rise of powerful computers has allowed for the automated analysis of vast amounts of data to sift through the cosmic noise. Studying our cosmic footprint. The new method, proposed by the team led by Penn State graduate student Penich Fan, flips the traditional SETI script. Instead of guessing where aliens might broadcast from, it starts by asking, if a distant civilization were looking for us, what would they see? Question mark. The logic is that by understanding our own transmission patterns, we can develop a targeted search for civilizations having similarity. To establish that baseline, the researchers analysed 20 years of data from NASA's Deep Space Network. The DSN is our planetary switchboard, a global system of antennas that sends commands to and receives data from our interplanetary spacecraft. The study found that our transmissions are not randomly distributed, they are highly directed and predictable. Humanity's strongest and most persistent signals are beamed toward our robotic explorers. We are constantly talking to spacecraft at Mars, Jupiter, and beyond. Because of our solar system is fairly flat, with most planets having formed from the same spinning disk of gas and dust, our transmissions tend to be aligned with this plane. As the researchers noted, the vast majority of our deep space communications are aimed within 5 degrees of Earth's orbital plane. These radio transmissions are powerful and focused, but they aren't perfectly contained. As a signal travels millions of miles to a probe, it spreads out, and a significant amount spills over to the space behind the target. This creates a predictable techno-signature for any distant observers who happen to be aligned with us and our target planet. The study quantifies this dramatically. If an extraterrestrial intelligence were in a location to observe an alignment of Earth and Mars, there's a 77% chance they would be in the path of one of our transmissions. As Fan noted in the August 21 press release, this is orders of magnitude more likely than being in a random position at a random time. During alignments with other solar system planets, the chance is reduced to 12%, but during times of no alignment, the chances are minuscule. This makes these predictable alignments the most likely times for civilization on Earth to be detected. Makes sense? If an alien civilization explores space in a similar fashion, their communication patterns might mirror our own. They too would likely be sending focused transmissions to their spacecraft. Think of our solar system as a dinner plate, with the planets orbiting on its surface because they are formed from that initial flat disk. Our deep space signals largely travel along the surface of this plate. To intercept a similar signal from another civilization, we would need to be looking at the dinner plate from the side. The edges of our plate would need to align with the edges of their plate. The most common method for discovering exoplanets is the transit method, which spots the slight dimming of a star as the planet crosses in front of it. This can only happen if we are viewing that system's dinner plate along its edge. Therefore, the transit method usually naturally selects for systems that are already in the geometric alignment needed for us to observe their planet's lineup. The team also calculated a practical distance limit based on the distance at which our spillover signal can be detected. An alien network equivalent to our own could be detected by a facility like the Green Bank Telescope from about 23 light years away, adding another crucial filter to the search. Researchers have already applied this technique to one of the closest and best known systems that meets those criteria. TRAPPIST-1. The system has 7 transiting rocky exoplanets packed in closely to its host star, making it a perfect laboratory for this technique. In a study published in late 2024, a team led by Nick Tussey, a graduate student at Penn State, used the Allen Telescope Array to conduct 28-hour radio technosignature search for TRAPPIST-1, or of TRAPPIST-1, with this planetary alignment technique. The team specifically observed the system during the 7 predicted planet-planet occultations, or PPOs. The precise windows when one planet passed in front of the other from our vantage point. After carefully filtering millions of potential signals, the researchers reported a null result. They found no evidence of signals of non-human origin. While not the detection SETI scientists were hoping for, the results demonstrated how practical the method is. Still, the new approach faces some skepticism. Jean-Luc Margut, an AUCLA professor who leads a SETI search with the Green Bank Telescope, believes success is more likely to come from a civilization deliberately advertising its presence with a radio beacon, as he tells Astronomy. This view favours searching for all over the sky, regardless of planetary alignments. While calling the alignment strategy reasonable, Margot notes its drawback is restricting the search to a very small fraction of the sky. He balances this critique, however, stating there are never any guarantees in SETI, so it makes sense to explore a variety of search techniques. His team has already searched around 68,000 stars for a deliberate signal. And while our catalogue of systems that meets the stringent criteria for alignment method is currently rather small, that is poised to change dramatically with the up-and-coming launch of NASA's Nancy Grace Roman Space Telescope. That's what they're calling it, Nancy Grace Roman Space Telescope. That's a new one. The telescope is expected to discover 100,000 new exoplanets, opening up a world of possibilities for SETI. Right, that was an interesting one. That's courtesy of astronomy.com. Now, I can see the time is getting away from me. All right, I'll bring up this next image. Let's just go and get rid of that for a moment and swap back to me, and then bring up this young lady, and let's briefly talk about her. On August 26, 1918 is the birth of Katherine Johnson. Today in the history of astronomy, the pioneering hidden figure is born. Born on August 26, 1918 in West Virginia, Katherine Goebel Johnson showed exceptional aptitude for mathematics from an early age. She skipped several grades, graduating high school by 14 and college by 18. Johnson was enrolled in West Virginia's University in 1939 as one of the first 3 black students to integrate with the state's graduate schools, but left before completing her degree in order to start her family. Then, in 1952, she heard about open positions in the all-black West Area Computing section of the Langley Laboratory for the National Advisory Committee for Aeronautics, or precursor of NASA. Her work was a key part of the early space program. She calculated the trajectory of Alan Shepard's Freedom 7 mission, and at John Glenn's request, checked the electronic computers calculations for this Friendship 7 orbital mission. She also contributed key calculations to the Apollo lunar missions and space shuttle programs. After becoming the first woman to be listed as a co-author on a Flight Research Division report, Johnson went on to author or co-author 26 research reports. She retired from NASA in 1986. And in 2015 she received the Presidential Medal of Freedom, and in 2017 the file Hidden Figures, a biography of Johnson and fellow NASA trailblazers, Dorothy Vaughan and Mary Jackson was released. Johnson passed away at age 101 in 2020. How's that? Amazing lady, and she lived a long time to see a lot of things happening. Really, really impressive, that lady there. And if you haven't seen Hidden Figures, the movie Hidden Figures, I highly recommend it. It is a top film to capture all that time history. This is VK3EKH, the official station of the Astronomical Society of Victoria. I see reports coming in from John John De Kaiser, one of the members of the ASV. He's listening to me on YouTube. G'day Dave, VK3AIF. Signals are loud and clear. And Steve, from a report from Steve, he says when AI already comes in, you'll be having a female robot reading the news. Yeah, well, we're looking at that. Oh yeah, that's actually a thought. Yeah, all right. Something that looks like me. a female version of me. Yeah, all right. Oh dear. All right, let's move along. There's a couple of other articles here that I'd like to cover. Where are we? Oh yeah. All right. There's a lovely little image here. Bring it up. There she blows. What is this, you may ask? Okay. August 23rd, 1991, water on Mercury. Today, in the history of astronomy, a map of the innermost planet reveals a surprise. In this 1991 radar image of Mercury, red means more reflective, while yellow and green are progressively less. The bright red spot at the top of the sphere indicates the presence of water at the planet's north pole. So on August the 8th and August 23rd, 1991, scientists from Caltech and the Jet Propulsion Laboratory turned the 70-metre dish antenna at the Goldstone Deep Space Communications Complex onto Mercury. The goal was to produce a radar map of the proportions of Mercury not photographed by Mariner 10 during its 1974-75 flybys. But to the researchers' surprise, the radar image received by the Very Large Array revealed reflective material at the planet's north pole, reminiscent of the polar caps on Mars and suggesting water ice. Although Mercury is the closest planet to the Sun and has an average temperature of 330 degrees Fahrenheit, or 167 degrees Celsius, with a maximum of 430 degrees Celsius, some craters rest in deep enough shallows for ice to survive. The axis on which Mercury spins is so tilted that in the polar regions the Sun barely rises. Temperatures in those craters can be as low as minus 148 degrees C. In 2012, NASA's Messenger spacecraft, which orbited Mercury, confirmed the presence of water. Amazing, absolutely amazing stuff. All right, you're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. And yeah, I'll read this out. This is the world's most powerful solar telescope. Captures its first monster flare in astonishing detail. Now, I'll just bring up this image, so stay tuned. Yep, okay. All right, quickly. The powerful NSF solar telescope has just delivered absolutely mind-blowing observations of its first X-class solar flare. On 8th of August 2024, the telescope managed to capture one of the most powerful flares our Sun is capable of producing at a remarkable resolution of just 4 Earth crosses. At a remarkable resolution of just 4 Earths across. So that's our resolution. If you can imagine 4 Earths in that image. This level of detail reveals some of the finest structures we've ever seen associated with a solar flare, opening up a new window into the sun's most extreme eruptions. This is the first time that the particular solar telescope, and there is a name for this solar telescope, but I'm not going to try and pronounce it, it's just something weird, has ever observed an X-class flare. These flares are among the most energetic events our star produces, and we are fortunate to catch this one under perfect observing conditions. And there is a kind of a video here, which I'll run the video. Let me see if I can just loop that. All right, so that's it in action there, alive. Weather from our sun can have some profound effects on our planet, with solar flares capable of knocking out radio communications for hours. We're unlikely to be able to change what the sun does, of course, but if scientists understand how solar flares occur, they can develop better prediction tools that may allow us to prepare ourselves. Just seeing what else there is to read. This particular space telescope is one of the most powerful solar observatories ever built, apparently, and it's revealing structures in the sun or on the sun at scales finer than we've ever seen. In its observations of the X 1.3 class flare that took place on August 2024, the solar telescope captured the smallest coronal loops ever seen. On average, these loops were 48.2 kilometers wide, maybe as small as 21 kilometers, right at the telescope's resolution limit of 24 kilometers. These loops are thin filaments of plasma that arc over the solar surface, following the magnetic field lines. They sometimes appear just before solar flares, which are powered by the energy released as magnetic field lines twist and snap and reconnect. Coronal loops are deeply relevant to the models of solar flare generation, but our telescopes have only been powerful enough to resolve loop bundles. This space telescope, more than twice the resolving power of the next most powerful solar telescope, and its captures of the flare represent the first time scientists have been able to see individual loops. We are finally peering into the spatial scales that have been We are finally peering into the spatial scales we've been speculating about for years. This opens the door to studying not just their size, but their shapes, their evolution, and even the scales where magnetic reconnection, the engine behind flares, occurs. We are finally seeing the sun at the scales it works on. And that research was published in Astrophysical Journal Letters. Yeah, that was fairly impressive. All right, let's just quickly go to spaceweather.com, as I usually do. Weather always seems to come to the end of everything. This is the current sun. And as you can see, there's quite a number of solar flares on that sun. The disk of the sun, if you were able to see it right now. The solar wind is currently at 420.9 kilometers a second. It is blowing a gale that'll be hitting us at midnight. Sorry, completely different thing. Anyway, at a density of 0.88 protons per cubic centimeter. The sunspot number is 201. The current sunspot number is 201. The radio sun is at 232 solar flux units. I don't think I've ever seen it that high. Measured at a wavelength of 10.7 centimeters. 232 solar flux units. That's enormous. But then if we have a quick look at our aurora over the South Pole, that's the current image for the Aurora Australis over Antarctica. So it's very faint at the moment. Not much solar or not much auroral activity occurring or to speak of. The current coronal image is that, so there's no big gaps in the sun's surface there, allowing high streams of particles to escape. What else have I got here to show? Oh yeah, the latest solar cycle. This is the current solar cycle. So this is where we are on the scheme of things. So we can see that we are now at the 1 o'clock position in the solar cycle. That's just a reference I make, but it is it is now on the decline. So we have reached solar maxima, as been said before, and as we come up towards the end of 2025, there is still quite potential for quite a lot of solar activity to occur. So it's not as if the sun is about to go quiet and radio communications is about to go back to normal. There is still a chance of some pretty decent flare activity to occur to energize our magnetosphere and the ionosphere and all that. So that's the current sunspot cycle. And another thing I was going to show too is the cosmic ray chart. Now, I don't usually mention this much, but generally during solar cycles, peak in solar activity, cosmic radiation drops. Almost once a week, spaceweather.com and students at the Earth to Sky Calculus fly space weather balloons to the stratosphere over California. These balloons are equipped with sensors that detect secondary cosmic rays, a form of radiation from space that can penetrate all the way down to the Earth's surface. Our monitoring program has been underway without interruption for 10 years, resulting in a unique data set of in situ atmospheric measurements, as you can see on the screen there. The latest results, as of November 2024, the atmospheric radiation is sharply decreasing in 2024. Our latest measurements in November registered a 10-year low. And as you can see on the chart there, it's 30% down. So what's going on? Ironically, the radiation drop is caused by an increasing solar activity. Solar cycle 25 has roared to life faster than forecasters expected. The sun's strengthening and increasing tangled magnetic fields repels cosmic rays from deep space. In addition, solar coronal mass ejections, CME, sweep aside cosmic rays, causing sharp reductions called Forbush decreases. The two effects blend together to bring daily radiation levels down. So, alright, who cares? Cosmic rays are surprisingly down to Earth form of space weather. They can alter the chemistry of the atmosphere, trigger lightning, and penetrate commercial airplanes. According to a study from the Harvard T.H. Chan School of Public Health, crews of aircraft have higher rates of cancer than the general population. The researchers listed cosmic rays, irregular sleep habits, and chemical contaminants as leading risk factors. A number of controversial studies go even further, linking cosmic rays with cardiac arrhythmias and sudden cardiac death. The radiation sensors aboard our helium balloons detect X-rays and gamma rays in the energy range of 10 kilo electron volts to 20 mega electron volts. These energies span the range of medical X-ray machines and airport security scanners. Data points in the graph labeled stratospheric radiation correspond to the peak of the Regina I can't pronounce it, Regina Povetso maximum, which lies about 67,000 feet above central California. When cosmic rays when cosmic rays crash into the Earth's atmosphere, they produce a spray of secondary particles that is most intense at the entrance to the stratosphere. Physics physicist Eric Gregener and George Pofsa, I don't know how to pronounce that silly name, discovered the maximum using balloons in 1930s, and that is what we are measuring today. So I haven't really read that out. That that whole thing is part of spaceweather.com, and I generally skipped over that. But the only reason why I mention it at the moment is because just recently I purchased a muon detector or cosmic ray detector, which looks like this. It's that's just one of them, not all those, but one of those is the unit. There's two detectors and the combining unit, and there's another image here showing the single unit. So it usually a radiation detector uses a Geiger tube type detector. Whereas this, what they refer to as a scintillator, actually is a slightly different concept, and it's using a polymer type plastic which reacts when charged particles goes through the polymer. And in this case, as the cosmic ray enters the polymer, it produces a charged an electron, which is then detected. And by having two of these scintillators on top of each other, if a cosmic ray enters the top one and enters the bottom one at the same time, that is definitely an indication of a cosmic ray that's been detected. And you get this little pulse on the crow that you're seeing in the background there. Well, I heard about this just only a few weeks ago, and I thought this would be an interesting thing to have to play around with, because I have been mucking around with a radiation detector up at our dark sky site many years, but that particular detector has failed, and so monitoring background radiation, gamma rays, alpha rays, and all cosmic rays has been offline as far as the observatory is concerned. And I thought, well, I'll just get my own detector. And I came across this one. This is relatively new, and this is the website. Now, the detector is browser based. It produces a real-time graph or chart across the screen by courtesy of using the browser in some fashion. I'm not 100% sure how that works, but it does. What is provided at the website of MDetect, it's mdetect.com, and look for under the education tab, and that's where you'll find more information about this EDU mod, EDU mod. And this is, at the moment, this is the screen that they're running that shows connected EDU mods to their server, and they're still developing this. There's still some things coming into fruition, because it's all relatively new. This educational muon detector is more targeting to universities and schools, but private researchers or people in public that are interested can still purchase these items for their own research and their own monitoring, and at the same time you can connect and upload your data to this site. Anyway, I'm still following up on it. It's relatively new sort of arrangement to me, and I hope to get it established on its own computer, because I'm currently using my main computer to run this unit on. I want to free it up and have its own computer running. So I just thought I'd mention that. It's like I say, the website is MDetect, Mike, M for Mike, mdetect.com, and look for the education tab, and you'll find more information about this EDU mod detector. It's a a fairly expensive unit, and you probably wouldn't be interested in buying one unless you're really keen, and I'm generally a bit keen on this stuff. So it comes in this little case. It's a very well designed thing, and what makes it expensive is that the new concept of detecting cosmic rays rather than a standard Geiger tube. Yeah, very, very interesting stuff indeed. Well, there it is. So I've gone well over time, but that's fine. If you guys have gone to bed, that's fine by me. Anyway, I'll leave it at that. I really did want to cover that as well, so I'll leave it at that. Yep. All right. I can just check out spaceweather.com for more information as well. Whew. Okay, let's call it quits. Right. Let me just take a glass of water here. And I might just mention, whilst I'm on air still, tomorrow morning is the ATV QSO party. I'm not sure its number, but the ATV QSO party's been going for quite a while now, courtesy of Peter Cousins, VK3BFG, who does a lot of the background work in setting up all these stations around the world to come in. So tomorrow, as advertised on the WIA broadcast last week by Peter, tomorrow is the ATV QSO party. So it kicks off at 10 o'clock in the morning, and with crosses to America, and then we'll pick up various stations around Australia, mostly stations from Adelaide, as well as I think there'll be one or two Tasmanian VK7s, and the local lads here will all be up there with their faces on the camera. So and then in the night, in the evening, I think from 7 o'clock onwards, will be crosses to the UK. So you'll be picking up a lot of ATVs in the UK, or a few of them anyway, that are prepared to come up. But a lot of the transmissions will be coming via the geostationary satellite QO100, because that satellite offers one channel to HD video, HD video stream. So it'll be interesting to see that. Again, they did it last year with great success. So it's amazing to see European ATVs coming in via a satellite through the internet. Yeah, anyway, that's tomorrow, the ATV QSO party. You can watch all activity on YouTube if you don't have access to the TV repeater here in Melbourne. You can view, if you type in VK3 VRS on YouTube, VK3 Victor Radio Sierra, VK3 VRS. Richard is running a YouTube stream which will just show everything that's going on for the whole day. And I believe there'll be the BATC stream. The British Amateur Television Club will have their video stream running, which is a direct feed from our repeater, the ATV repeater. So you can watch it through there. I think that's about it on the ways to see it. Otherwise, here's your opportunity to get yourself a set-top box. tune the set-top box to 445.5, and when you know that the repeater is operating, do a scan and see if you can see it. It's the repeater is located at the back of the police academy up at Wheelers Hill, or Mount View as it's called. It's the transmitter is located at the top of the tower, right at the top of a 100-foot tower. It's a vertically polarized signal, vertically polarized at 100 watts or so. DVB-T2. Your set-top box must be capable of receiving DVB-T2, as in number 2, DVB-T2, which is HD transmission. Yeah, so you can find the set-top boxes on many places, eBay and all those other weird websites, Chinese websites. But if you go to Australian Amateur Radio Victoria, so Amateur Radio Victoria, I should say, ARV, Amateur Radio Victoria, and there's one dedicated page to RTV and how to view it. That's probably the best source of information, is the RTV page on Amateur Radio Victoria website, and or vk3rtv.com. There's another homepage for the repeater, vk3rtv.com, to find out more information. All right, that's tomorrow anyway. It should be a bit of fun, as it normally is. All right, now let's see if there's any stations still around. I mean, if everybody's gone home, that's fine by me. I'll give it away. So this is VK3 EKH having a quick listen on 3541 kilohertz for any stations wishing to check in. All right, VK3KIS and VK3SBX. Any other stations? Well, that's what I was going to expect. Have a say, Andrew. VK3KIS, VK3EKH.
Good evening, Chip, and all on the group. Doing well. And, about the blue shift a few weeks ago, and for the life of me, I cannot remember if you've done an article on blue shift since then. I'd just be interested to get the point of view to see if anything's been observed in that regard, because we're always hearing about the red shift. But as far as this evening's is concerned, the images that they get from the sun and the fact that they got very cold regions and it's absolutely mind-boggling. Anyway, thanks for doing it. It's VK3EKH, VK3KIS.
Yeah, okay, Andrew. Can you? I'm not too sure what you're referring to. Was it something about the sun or some other thing? The images. There's a few lightning crashes just playing around with your signal, and I didn't quite catch what it was exactly. Whether it was images from the sun or something else. Go ahead.
I was talking about the blue shift, not necessarily the sun, but observations in the astronomy arena to see if there are any blue shifts over.
I'm not getting that word. It sounds like you're saying ablutions. I'm not sure exactly what it is you're trying to say, Andrew. Go ahead.
Okay, I'll turn the wick up all the way. Blue shifts, as in the colour blue. If you're cold, you're blue. Over.
Right. Okay. That's a better signal from you now. So something about blue. Blue what?
Blue shifts. We often hear about the red shift in the expanding universe. Are we hearing anything about the blue shift? Has anything been observed? Over.
Now I get you. Sorry, I do apologise, Andrew. Now I get what you're saying. Whew. Okay, we got there. All right, so the next question is the blue shift on what particularly?
Has it ever been observed in the astronomy field? Over.
Oh, okay, I can see. Yep, all right. Yes, I think so. It's interesting. That's an interesting question, because if we look at hydrogen is the most abundant gas in the universe, and when it comes to doing radio astronomy, most of the hydrogen that we see is redshifted, or going away from us. It really depends. That of course depends on a lot of other factors, like the Earth's rotation, the Earth's position in the galaxy, and in reference to all the other sources of hydrogen that we can see. Initially, initially the map that was generated of our spiral galaxy was through hydrogen analysis, radio astronomy, and until that research was done using the hydrogen line, to measure red and blue shift. So when we're looking at hydrogen in the universe, we are seeing parts of the universe that are moving away from us, and parts of the universe or the galaxy that's moving towards us. So the blue shifted aspect we can detect and we can see, and it's because of that, the fact that we can measure the shift or the velocity of the variety of our spiral arms. We were able to determine the general shape of our galaxy, and that's where we've come to the realization that we are living in a spiral galaxy purely because of the signature that is given off by the hydrogen line at 1.4 gig, 1.4202 gigs. So that comprises of radiation that is moving away and moving towards us, depending on our relative position in the universe. So it's interesting because in most cases, a lot of what we see in the universe is moving away from us and accelerating. So a lot of objects do have a red shift associated with them, and I know that when it comes to looking at red-shifted objects at the hydrogen line, it can be so red-shifted that the signature of hydrogen is moved down to around 100 megahertz. I mean, from 1.4 gig down to 100 megs. That's a big shift, representing objects that are very, very, very far away. And this is where the ASCAP and the very large array, or the 1 square kilometre array project, is going to shine, because it's looking at these low frequencies for this sort of measurement. But look, I'll do a little bit more looking into that for next week, and I'll see if I can find out more information that targets blue shifting objects. I would imagine that because, for instance, the galaxy Andromeda M31 is heading our way, that it would probably have a blue shift associated with it. Let me look into that and see what is determined from that point of view. It's an interesting thought. I'll get back to you. I now know where you're coming from, so it took a little while to get there. No worries, Andrew. VK3. I'll just pop it back to you. VK3KIS, VK3EKH.
Okay, I appreciate a little research, because I haven't been able to find much on the subject myself. Okay, I'll leave you to go into the next station. Thanks for doing it. VK3EKH, VK3KIS, 73, mate.
No worries, Andrew. And that's a great signal now that you've turned up the wick. All right, Steve, VK3SBX, VK3EKH.
VK3EKH, VK3SPX. I hope I've got my wick up. I joined the net yesterday with a power set at 12%, and I couldn't figure out why I was getting lousy reports until I thought to have a look at the power. That was an interesting question of Andrew's. I did a bit of Googling while you were talking about that, and yes, indeed, some of the local galaxies do show a blue shift. And Andromeda is the first thing that occurred to me too. I don't know if it would be significantly blue shifted, because it's relatively close compared to the ones hundreds of billions of light years away. And another interesting thing I found out, apropos of nothing in particular, in terms of redshift, usually attributed to something moving away. But apparently, and you can ask Sabina about this, you know who I mean, light actually loses energy travelling through space after millions and millions of years. So a certain proportion of the redshift is due to the actual photons losing energy and thus becoming, with a lower wavelength. So I thought that was pretty interesting, although I don't understand it an awful lot. Interesting about the QSO party. The Bendigo club up here is getting into ATV a bit too. So anyway, I might have a bit of a look at that from the British ATU stream tomorrow. It's interesting about the cosmic rays. It's sort of inversely proportionate to the solar activity. That's kind of interesting, isn't it? Makes sense, but I didn't know about that either. And all sorts of useful things there as well, although I did join late. I did look at that Hidden Figures film about Katherine Johnson, and that was a very, very good movie. And I'll leave it there rather than waffle on forever. I'm with you on the more Carrington events, though. That amateur rate would really shine there, wouldn't it? If we had a good Carrington event, as long as we remember to disconnect our antennas beforehand and connect them up again afterwards. So yeah. Okay, all right, thanks, Cliff. I'm afraid I think I'm going to miss a game next week, because I've got to go to the club committee meeting. But anyway, I might join later, or I might be see you in a fortnight. EKH or the VK3SPX?
Yeah, it's no worries, Steve. It's all cool. VK3SPX, VK3 EKH returning, not a problem at all.